Hey everyone, and welcome back to our AI training series. If you caught our first session, you now have a solid understanding of what artificial intelligence is and its broad scope. Today, we're diving deeper into the heart of modern AI, machine learning. What we'll cover today? In this session, we're going to demystify machine learning. You'll learn the core definition and goal of machine learning, why data is king in the world of ML. The three main types of machine learning: supervised, unsupervised, and reinforcement learning, with practical examples. A look at some common ML algorithms and what they're used for. And finally, the machine learning workflow, the steps involved in building an ML model. By the end of this session, you'll have a clear picture of how machines learn and why it's so powerful. What is machine learning? So let's start with the fundamental question. What exactly is machine learning? As we briefly mentioned in the last session, machine learning is a subset of artificial intelligence that empowers systems to learn from data without being explicitly programmed. Think about it like this. Instead of writing lines and lines of code telling a computer exactly what to do for every possible scenario, we provide it with a large amount of data and let it figure out the patterns, rules, and insights on its own. It's like teaching a child by showing them many examples rather than giving them a strict set of instructions for every single object they encounter. The goal of machine learning is to build models that can make predictions or decisions based on new, unseen data after having learned from past examples. The importance of data. Now, if machine learning is about learning from data, then it should come as no surprise that data is absolutely crucial for any ML project. Your data acts as the teacher for your machine learning model. Quality over quantity, but both are great. The better the quality of your data, meaning it's accurate, clean, and relevant, the better your model will learn. Garbage in, garbage out, as they say. Representation matters. Your data needs to be representative of the real-world scenarios the model will encounter. If you're building an AI that recognizes cats, showing it only pictures of dogs won't work. Feature engineering. Often, raw data isn't enough. We need to extract or create meaningful features from the data that the model can learn from. For example, if predicting house prices, features might include square footage, number of bedrooms, or location. We'll dive much deeper into data preparation in a later session, but for now, remember, no good data, no good machine learning. Types of machine learning. Machine learning can be broadly categorized into three main types based on how the model learns from data. Let's break them down. 1. Supervised learning. First up is supervised learning. This is the most common type of ML you'll encounter. In supervised learning, the model learns from a labeled data set. This means that for every input, we provide the corresponding correct output. Imagine you're teaching a child to identify animals. You show them a picture of a cat and tell them, this is a cat. You show them a picture of a dog and say, this is a dog. The label is the animal's name. Supervised learning is used for two primary problems: classification, predicting a categorical label. For example, is an email spam or not spam? Binary classification. What type of animal is in this image? Multi-class classification. Will a customer churn or not churn? Regression, predicting a continuous numerical value. For example, what will be the price of a house next year? What is the temperature going to be tomorrow? How many sales will we make next quarter? 2. Unsupervised learning. Next, we have unsupervised learning. This is where things get a bit more exploratory. Unlike supervised learning, in unsupervised learning, the model learns from an unlabeled data set. There are no correct outputs provided. The model's job is to find hidden patterns, structures, or relationships within the data on its own. Think of it like giving a child a pile of random toys and asking them to sort them into groups that make sense to them, without telling them what the groups should be. They might group by color, by type, or by size. Common uses of unsupervised learning include grouping similar data points together. For example, customer segmentation, finding different groups of customers based on their purchasing habits. Document topic modeling, grouping news articles by their subject matter. Dimensionality reduction, reducing the number of features in a dataset while retaining important information. This helps with visualization and managing complex data. Assertion rule mining, discovering relationships between variables. For example, customers who buy bread also tend to buy milk. This is popular in market basket analysis. 3. Reinforcement learning. Finally, let's talk about reinforcement learning. This type of learning is inspired by behavioral psychology. In reinforcement learning, an agent, the machine learning model, learns by interacting with an environment. It performs actions and receives rewards for desirable outcomes and penalties for undesirable ones. Over time, the model learns to perform the trick to get the reward. Reinforcement learning is particularly powerful for game playing, AI agents that can master complex games like chess, Go, or even video games. Robotics, teaching robots to perform tasks like grasping objects or navigating complex terrains. Autonomous driving, training self-driving cars to make optimal decisions in various traffic scenarios. Common machine learning algorithms, briefly. While we won't deep dive into the math today, it's good to know some of the popular algorithms within these categories. Supervised learning, linear regression for predicting continuous values, example, house prices. Logistic regression for binary classification, for example, spam detection. Decision trees and random forests for both classification and regression, intuitive and powerful. Support vector machines, SVMs, for complex classification problems. Neural networks, the foundation of deep learning, incredibly versatile for complex patterns. Unsupervised learning, K-means clustering, a popular algorithm for grouping data points into K-clusters. Principal component analysis, PCA, a common technique for dimensionality reduction. The machine learning workflow. Now that we understand the types of learning, let's outline the general workflow for a machine learning project. This is a cyclical process, and you'll often iterate through these steps. 1. Problem definition. Clearly understand what problem you're trying to solve with ML. What's the goal? What's the desired outcome? 2. Data collection. Gather the necessary data from various sources. 3. Data preprocessing. This crucial step involves cleaning the data, handling missing values, outliers, transforming it, as in scaling, and selecting relevant features. This is often the most time-consuming part. 4. Model selection. Choose an appropriate ML algorithm or model architecture based on your problem type and data characteristics. 5. Model training. Feed the preprocessed data to the chosen algorithm to train the model. 6. Model evaluation. Assess the model's performance using appropriate metrics. Is it accurate enough? Does it generalize well to new data? 7. Model tuning, hyperparameter tuning. Optimize the model's performance by adjusting its hyperparameters, settings that are external to the model itself. 8. Deployment. Once satisfied, integrate the trained model into a real-world application or system where it can make predictions. 9. Monitoring and maintenance. Continuously monitor the model's performance in production and retrain it with new data as real-world conditions can change.
What's next and conclusion? And there you have it, a comprehensive overview of machine learning. We've covered its definition, the importance of data, the three main types, some common algorithms, and the general workflow. This session provides the essential foundation for what's coming next. In our next video, we'll take another significant leap and explore deep learning, understanding how those multi-layered neural networks revolutionize AI. I hope this session has clarified how machines truly learn from data. If you have any questions or want to share your thoughts, please leave a comment below. I love hearing from you all. Don't forget to like this video and subscribe to the channel if you want to keep learning and stay updated with our series. Thank you so much for joining me today. I'm excited to see you in the next session as we uncover the power of deep learning.